Greetings everybody. I'm delighted to have you back in another round of AGC webinars. My name is Suzana Ayeti, Account Manager for AGC and the PCB's organizer for this session. Today we will discuss about design of CCP monitoring program in food safety. We will clarify the definition of CCP and monitoring as well its role. To talk about this and much more, joining us is PCB's certified trainer and production manager of Homefoods processing in Cannery, Mr. Samuel Oppong. Feel free to write your questions and comments in the question box in the right-hand control panel, and Mr. Samuel will answer to them accordingly. Moreover, if you want to participate directly in the discussion with Mr. Samuel, you can also raise your hand and then we will unmute your microphone and you can make your questions directly to him. Please, Mr. Samuel, you may start the presentation.
Thank you and good afternoon to you all. Good morning or good evening, depending on where you are. I'm in Ghana now, so it's afternoon. My name is Samuel Oppong and I'm happy to share with you on today's presentation the design of CCP monitoring programs. There's a little bit information about myself. A certified trainer with PECB. By way of introduction, I would just want to say that the proper design of CCP monitoring program is an essential ingredient in any food safety management system that is capable of producing safe foods. For this reason, I'm focusing my presentation today on the monitoring aspect of food safety, and specifically I'm zeroing in on the CCP, which means critical control points. I'm expecting that by the end of the presentation we will have a better appreciation of what we mean by CCP and monitoring. Again, I also want to expect that we will appreciate the role or the importance of CCP monitoring in any food safety management system. And then finally, hope you will acquire some techniques or skills that will help you to design and then implement a very effective CCP program. Before we can actually examine the details of what an effective CCP monitoring program is, it's very important that we have to clearly define what we mean when we say CCP and when we say monitoring. So I want to take this opportunity and define these two terms for our understanding. When we say CCP, these are definitions that are widely used from ISO 22000-2005 reference. It defines critical control point as a step at which a control can be applied, and this control is essential for the prevention or elimination of a food safety hazard or reducing it to an acceptable level. We all know that all food manufacturing processes are made up of a sequence of steps or activities or stages through which we arrive at our final food product, which we distribute to our customers. Now, depending on the process, there could be a step or one or more steps, specific steps within the whole process, in which if it is not maintained under control, it can lead to consumers becoming ill or maybe becoming impacted negatively. So those steps which, when control are not put in place, they will lead to consumer hazards or consumer health issues. Those steps are what we refer to as critical control points. And I want to, in my view, define, in other words, critical control points are the last line of defense for food safety, which means that those are the stages that when defense or control is not put in place, the product gets to the consumer in an unwholesome or unsafe condition. When we talk about monitoring, ISO 22000-2005 also defines it as the act of conducting a planned sequence of observations or measurements. And the essence is to assess whether control measures are operating as intended. By this, we view monitoring as an activity that an organization or a company will conduct that is focused on measuring and collecting data that are related to the controls that have been put in place. So this information normally allows the company to decide whether the CCP is really under control or not, and for that matter, whether we are processing or producing safe food or not. This is what monitoring is. Prerequisites to CCP monitoring. We all agree that no matter how a process is, there are inherent variation that is inevitable. Every process, there are variations with it. So it is very important that we implement a very effective CCP monitoring program that can monitor and check whether these steps are under control. Before implementing those programs, there are two main things that should be done, which are called the prerequisites. One is to determine the critical control points. And this is very important, and it's important that we get this right, because monitoring in most cases is an expensive business. A lot of resources will have to be committed into it. And when a company has limited resources to share, obviously it would like to dedicate those resources to the most critical aspects of his or her process. So this is where the CCP determination comes in. So we need to identify among our processes what are those stages that are critical, that will need monitoring. And basically, to identify the CCPs, there are various methods. One of the normal methods is using a structured decision tree to arrive at whether a step or a stage is a critical control point or not. The second thing is to establish the critical limits for each CCP. The critical limits, according to the principles of HACCP, it should be determined for each critical control point. What we mean by that is that the critical limit will give us the acceptable limits, or the limits above which a food safety hazard, when it's exceeded, it means the product is not safe. So the critical limits normally express our purest form of our food safety program. So they should tell us what are the limits that the hazards can be acceptable for us. In most cases, some of these critical limits are parameters which are commonly used, like temperature or time or pH, acidity, and so forth. But there are instances where the critical limits is based on subjective data, which means it's based on visual inspections and the rest. So some critical limits are measurable with values or control parameters. Some will be by subjective data. CCP monitoring program. As a rule of thumb, we always say that whatever critical control program, monitoring program that you are implementing, the focus is that it should be geared towards timely detection of loss of control. Why? Because we want to protect the consumer from possible exposure to the food safety hazards. So the whole idea or essence of the monitoring is to check whether we are achieving control. And if we are not achieving control, we also want to know in a very timely fashion whether we are not. And this is one of the main objectives of monitoring as far as food safety is concerned. So this is the structure of the components of a food or CCP monitoring program. The components are the monitoring methods, that is the procedures that will be used, the devices or equipment, monitoring equipment, the monitoring frequency, as well as the CCP monitor, and then the monitoring records and documentation. We want to take time and go through these things one by one. The first thing is to design your monitoring methods. Now, the monitoring methods, we have two different cases. One of the cases is whereby you measure a process parameter at the CCP. One thing that should be clear is that the food safety hazards at the CCPs most often cannot be determined directly, or it's not practicable to determine the hazards, especially these pathogenic hazards, directly. So normally a secondary parameter is used to determine or control their levels. So the monitoring method can be geared towards measuring the process parameters. And under this case, we have two methods, the online and then the offline. The offline systems are the ideal system setup for CCP monitoring because they give us automatic data or results while the process is still going on. But I must say that most often is very, very expensive and always is not practicable. The offlines are, majority of the CCP monitoring programs are on the offline system basis, where it tends to be manual. The offline systems are manual in nature and involves taking samples, for example, and then measuring those critical factors like the pH, like the temperature, and those things. And the assumption when we are doing the sampling is that the sample is representative of the process. This is the other case of monitoring. You can have one monitoring method which is based on observation or inspection at the CCP. So in some cases, normally the critical limit, like I've earlier explained, will not be a measurable value, but it may involve an event or a task that has to be occurring at a defined interval. So this is also another case where we can have observation going on. I listed some examples here. Some organizations consider checking of certificates of analysis of incoming raw material. This as an activity, a monitoring method or a monitoring activity. And other examples also like the GMP inspections every shift. So this is also the other bits of the monitoring methods. Let's share some tips on the monitoring methods. Fundamentally, I would like to say that the monitoring methods must allow for timely results. That is where it is most critical. Whatever monitoring method you want to implement, it should allow for a timely result. Lengthy testing procedures, which in some cases will give you results after days after the event, are not they are of little value. What I mean is that, for example, there are some microbiological testings where the results will be available some days after the event. Those type of monitoring methods are not really preferred compared to other physical and chemical measurements. So most often the physical and the chemical measurements are preferred because they give rapid results, and those rapid results enable the company to take decision on time in order to control any deviations from the critical limits. Some of those physical and chemical monitoring programs in the food industries come across, like the time and temperature measurements, which is mostly used to address microbiological hazards. there is also the water activity measurements, and then the pH measurements. Some of these things are very rapid in nature, and they provide timely results. So most people recommend that those type of measurements should be preferred or used compared to other microbiological. Microbiological can be used during monitoring of the whole food safety management system program. Now a little bit on the monitoring device. Obviously, the type of monitoring program or the monitoring method that you will implement will determine the selection of the monitoring equipment. So if you choose to go with these physical and chemical or physicochemical measurements, then it comes along with its monitoring equipment. But you can have equipments that are used for monitoring CCPs can vary. And most often there can be a number of options for measuring even the same parameter. For example, acidity, some people would like to measure by thermometry. Some people also want to go with the pH meters and the rest. But fundamentally, or once again, the emphasis is in all these cases, the equipment used for monitoring must be accurate, and it should ensure the control, valid results at the control point. So this can be achieved by calibration or standardization. And by calibration, we mean we want to compare the measuring sensitivity of your instrument with a reference or a standard one. So it is very important that whatever monitoring equipment that are being used, they are periodically calibrated or standardized so that their results can be valid or validated. We can share some on the monitoring frequency. Ideally, if it is continuous, it is the best. And I must say that those instruments that automatically produce continuous records will not control the hazard on its own. So even if you are using a control system, you should find there should be in the setup some form of alert that the user can immediately detect deviations when it occurs, so that we reduce the amount of products that has to be reworked or product loss when the critical limit is exceeded. But we also have the non-continuous monitoring frequency. But in determining the intervals between the checks, we need to consider, for example, the risks of the product or the nature of the hazard or the existing controls. For example, if you have control like this microfilter in place for controlling maybe the physical hazards like stone or sandy matter or particles, because of this nature of the control, you can be monitoring at this, you can be monitoring this maybe per shift basis. On the other hand, if you have, let's say, this microbiological hazards, and maybe in a process like pasteurization of milk, where the time and the temperature is of essence, these monitoring intervals will also have to be shorter so that you can detect any possible deviations from it. So in all these cases, once again, the tip is that the checks must be performed in time to ensure that irregular product is isolated before shipment is done. To get the frequency, to establish the monitoring frequency, you can determine this from historical knowledge of your product or the process. So you need to consider your process or your product and then evaluate it, and then you will be able to establish the non-continuous monitoring, the frequency that should be there. But the length of the time between the checks will affect the amount of rework. So we have to take that into consideration. The other aspect of the program is the critical control point monitor. It has always been said that since the food safety program management system involves people, people are key to the program, and they are also very their presence by use of people, they also pose risk to the whole program. So it's very important that the people that are put in charge of the monitoring of the critical control points, they can come from any layer within the organization. For example, they can be supervisors, they can be line personnel or quality assurance personnel or maintenance personnel. But the point is that these people need to be adequately trained on the CCP monitoring techniques, because when the training is not given, it makes the monitoring weak. And when monitoring is weak, the food safety control or the entire food safety program is also weak. So people responsible for monitoring should be trained. They need to be made aware about the importance of the CCP monitoring. Well, as we have established, when control is not applied at those critical control points, there could be a health impact on the consumer. The people at the critical control points monitoring should have ready access to monitoring activities. So those people should be trained on that. They should produce reports. They are required to produce reports that tell in a timely manner when deviations are observed, and also the corrective actions that should be taken. So these CCP monitors have a very important role to play as far as the whole program is concerned. The training, the awareness, and the record keeping should be adequate for these people. I would like to say that normally the company, the monitoring, should be as close as possible to the step. What I mean by that is you cannot have the CCP monitor, a distance away from the point of control. So if it is a machine, I would prefer that the equipment operator should be the CCP monitor. He will be responsible for the daily monitoring of it. So when control is brought directly at the base of the monitoring step, it helps a lot rather than moving it far away the organizational structure. The last thing we want to talk about is the record keeping. As a matter of fact, it's required that documentation should be kept on all the monitoring. The records are a special type of documentation, and they provide evidence that the monitoring activity has been performed and is within the critical limit. So each program should have in place a record for all the results and clearly defined or documented procedure for conducting these things. These procedures normally should be written by people who are highly trained in HACCP or food safety management system. And these procedures should be made available to the CCP monitors, and they should adequately understand and follow those procedures. So the records you can have a number of options. Some companies use the electronic method, or some also go with the semi-manual method. I think the manual method is now also using paper, but it's very quick. Use of paper is very quick. It requires less training, but the errors are so much, and the data analysis is time consuming. So people are looking at electronic way of keeping their records, which is by several applications, software applications, which is more easy to validate and easy to analyze the data for control. So basically, this in brief, is some of the information that I can share with regards to designing of critical control point monitoring program. Thank you, Susan. Hello, Susanna.
Yes, Mr. Samuel, thank you for this presentation. Our attendees have made some questions, so I would like you to answer the following. What to do if monitoring detects a deviation?
Thank you. When monitoring detects a deviation from the critical limit, obviously within the HACCP documentation there should be provision for corrective action, because no matter how robust your system is, even though we hope to be preventive and prevent deviations, but deviations, some are inevitable. So there should be corrective actions in place in your HACCP plan, so that when you have deviations or when your critical limits are exceeded, those corrective actions can be initiated and then implemented. So the corrective actions, you can have the correction and then the corrective actions. When you exceed your critical limits, first and foremost, the correction will be looking at dealing with the non-conforming products. That is one aspect. So the non-conforming products, the products that have passed through at the time when the deviations have exceeded, if they are non-conforming products, then you have to take some corrections, i.e. maybe rework it or segregate it, or you take correction on that. And then you also take the other one is the corrective action, which deals with the root cause of the detected non-conformity. So you need to, these are the two steps that can be taken when your CCP critical limits are exceeded. Thank you. Hello?
Can you hear me?
Yeah, I can hear you.
Great. The other question is CCP monitoring an expensive process? And what should a company do if they don't have enough money to do CCP monitoring?
Yeah, if the fact is that no matter how robust your food safety controls or your food general management system is, if your monitoring program is very weak, then I can assure you that your entire food safety program is also weak. So that is why you need to invest into the monitoring at those critical control points to make sure that the products are safe at the point of delivery. So what I'm saying is that if the company has the necessary resources to do the monitoring, that's what I'm saying, the critical control points should first be identified so that resources are not wasted. Those resources can be applied to those critical control points. And if it is the online system that the company wants to go for, which is like the ideal system for monitoring, because they are able to detect the deviation early or on time, which is the essence of monitoring, and also prompt or take the necessary corrective action. Those systems are preferable. So if the company has the necessary or the adequate resources to go into the online system, that's ideal.
Thank you. The other question is, can you give us an example regarding a problem that occurred during CCP monitoring and what was done to solve it?
Hello?
Yes, Mr. Samuel, can you hear me? Hello?
Please, can you come again with the question?
Yes, okay. So it says,
Hello?
yes, I can hear you, but I don't, can you hear me?
Okay.
Okay, great. So once
Yeah, now
again,
I can do.
great. So once again, the question is, can you give us any example regarding a problem that occurred during CCP monitoring and what was done to solve it?
Thank you very much. So in our dairy or yogurt production, we needed to establish pasteurization so that the temperature was determined, and then the time also was determined. So the monitoring showed that the temperature was below the ideal setting. So for those batches, they needed to be segregated immediately and then reprocessed. That was in yogurt production.
Attendees for taking the time out their busy schedule to join us. And we hope you enjoyed this webinar. We received all your questions, and because the time is limited, we will answer to your questions individually by email. Also, don't forget to check PCB's webinar schedule on our website, pcb.com, or our official social media network. Thank you once again. Bye-bye.